Another example of a story problem using equations involves mixture problems. Mixture problems sometimes are involving, as the example is going to be here, mixing solutions. Sometimes it has to do with different types of money with coins and such. But we're going to look at a classic example of mixing solutions. Now this one only has two of them that you're combining, but you can have as many as 3 or 4 depending on the length of the problem and the author of the book. How much 4% acid solution should be mixed with 200 milliliters of a 12% acid solution to make a 9% acid solution. One thing you may want to make note of is that the mixture, the percent of the solution, has to be somewhere in between. Now if it turns out to be exactly in between, which would be say 8%, then you need equal amounts of the two things that you're mixing. But since this is 9%, a little bit bigger, a little bit stronger, let's say, than an 8% solution, you figure you need a little bit more of the stronger mix than the weaker stuff. But in this case, I don't know how much 4% acid solution there is, so that's my variable. I'm going to let x represent the amount of 4% acid solution. Now, this is in milliliters. That doesn't mean I have X milliliters of pure acid. I have X milliliters of 4% acid solution. I also have 200 milliliters of 12% acid solution. Now how much pure acid is this stuff? Well, if I have this many milliliters and 4% of it, that would be 0.04 times X would be the amount of acid from the 4% solution. How much pure acid? And we have 12% acid solution, 200 milliliters of that. So if I take 12% and multiply that times 200 milliliters, that would be the amount of pure acid from the 12% solution. Now, our mixture is to be 9%. By the way, if you take 0.12 times 200, you're going to get 24. This is going to be 24 here. But if we have 200 milliliters of the 12%, X milliliters of the 4%, that means we have X plus 200 milliliters of the mixture, which is at 9%. So that means how much pure acid is that? 0.09 times the amount of the solution. And that would be the amount of pure acid from the mixture. Now the reason I'm writing it all out like this, and a lot of textbooks will show you a table to set it up that way to be more organized, but what we're going to do is we're going to add the amount of pure acid from the two things we're mixing, and we're going to set it equal to the amount of pure acid in the final mixture. Because if you put the two things together, that's the mixture. So I'm going to have 0.04x of the 4% solution being pure acid. I'm going to have 24 milliliters of pure acid from the 12% solution, the 200 milliliters of the 12%. And if I add those together, I should get how much pure acid is in the mixture, and I'm going to have to distribute here X plus 200. Now this is 0.04x plus 24 equals 0.09x plus, now that will turn out to be 18. 100 times 0.09 is 9, so 200 is 18. I'm going to get the variable on one side. Now if you don't like the decimals, multiply through by 100, but these are not that bad. There's only 2 of them, and they're like terms. So I'm going to subtract 0.04x to get the variable on from both sides to one side, and at the same time I'm going to get rid of the plus 18 by subtracting 18. So I'm going to do both in the same line here. Oop, one too many zeros. Don't get careless, which I just did. Plus 18, and then I'm going to subtract the 0.04x, and I'm going to subtract the 18. So that gives me 6 is equal to 0.05x. Now I'm going to divide both sides by 0.05. So 6 divided by 0.05 equals 0.05x divided by 0.05. And I'll just flip the x over to the other side. And if this is messing you up, computer's happy, you can multiply top and bottom by 100. That would give you 600 divided by 5, or 120. So 6 divided by 0.05, check it with your calculator, is 120. X, remember, is the amount of the 4% solution, and that's what they're asking for. So there should be, don't forget your units, 120 milliliters of 4% acid solution. Let's see if this makes sense before I stop on this problem. A little bit ago I said that exactly halfway in between would be 8%. And 8% would mean that you would have equal amounts. This is 9%. So if you have 200 milliliters of the stronger stuff, and this is a little stronger than halfway, it would make sense that this would be a lesser amount than 200. And it is 120, and that's a lesser amount. So that kind of makes sense. And just double check your work, and of course